Now this is a question that we're supposed to find the relative formula mass of Q. Okay, so what is Q? Q is a carboxylic acid. That means the functional group is COOH, right? We use an aqueous solution containing 4 grams of Q. When this solution reacts with excess magnesium, then 380 centimeter cube of gas is produced, measured at STP, right? We are very familiar with the volume of gas measured at RTP. Okay, not very common for them to ask STP, but not to worry. You go to any paper 2, at the end of the paper 2, you'll be given a periodic table and also a table like this for important values, constants, and standards. Now remember this, all these values will be given to you in the exam, so you do not have to memorize these values. Now back to our question, the volume of the gas produced is measured as STP. So 1 mole of gas will occupy 22.4 decimeter cube per mole. Okay, that means 1 mole of this gas will occupy 22.4 decimeter cube at STP. So this will be the value that we are going to use in the calculation, 22.4. And again, okay, these values will be given in exam, so do not have to memorize them. So now we go back to the question. So that means this 380 centimeter cube of gas is measured at STP. Okay, and at STP, 1 mole of gas, okay, will occupy 22.4 decimeter cube. So let's write down here first because we're going to use this later. Okay. Now, a carboxylic acid, I do not know the full structure of Q, so I'll just put the hydrocarbon side chain as R. Any carboxylic acid will react with magnesium to form magnesium carboxylate salt. So MgRCOO2, right? Because this RCOOH is an acid, it will donate the proton away. Magnesium will accept the proton, okay? And then they will form also hydrogen gas. So, okay, what will happen is because of this formula, 2 moles of Q will react with 1 mole of 1 mole of magnesium to produce 1 mole of hydrogen gas. Okay, now we have this equation. Now I'll be able to find the number of mole of gas, in this case hydrogen gas, right, by using the volume of gas at STP. So 380 divided by 22400. Okay, 1 mole will occupy this much space. So 380, what's the number of mole? We divide, okay, by 22400, and then I get the answer 0.0170 mole. Now from this equation, I know that 2 moles of Q will produce 1 mole of hydrogen. So the number of mole of Q is the 2 times the number of mole of H2 because the ratio is 2 to 1, right? Okay, so the number of mole of Q is 0.0340 mole. And there's another formula that we can find this number of mole. Okay, 0.034 is the mass of Q divided by the relative formula mass of Q. So MR of Q. From this, okay, we can find the relative formula mass of Q, which is 4 divided by the number of moles. So the answer is Okay, from my calculator is 117.6. Okay, all the answers, no decimal point. So I have to round this up to 118. Okay, by looking at the answers, it should be